Okay, this is How to Teach Git. I'm Georgia Reh. So first things first, does everyone here know Git? Yes. Okay, good. I'm assuming you need to teach it to someone. So I'm going to be going over how to teach to absolute beginners, people that have either limited experience with programming in Bash, or this is just their first time with version control, or first time using version control. I'm not going to be teaching you like a specific curriculum because I don't know your students. I don't know what their experience with Bash and other version control is. So if you want a tutorial, go find one online. There's lots of them. Most of them are fantastic. But what I'm going to be doing is basically sharing the weird stuff people have gotten confused about when I was teaching to sort of prepare you for the potholes that your students are going to run into. So here we go. So the first step when teaching Git is to make sure that your student actually knows what Git is for. If you just say, this is version control, and you're going to need it, your student's going to be pretty confused when you start talking about graph theory. So step one is to explain why we need to be able to have version control, how Git helps you to work with others. Start by building a context and giving them a sense of what this tool is for. Because that way when you start explaining how Git solves the problem, it'll fit inside of this narrative. Okay, so at the very beginning, when people are first learning tech stuff, it's hard to remember that Git is actually a really difficult tool, and it's very complicated, and it seems very easy to us. But when they're on their first day, they need to know how to use Git, not how Git works. So just remember that we're laying groundwork for them. We're not going to teach them all of Git. We're not going to talk about the cool, complicated stuff it does in the file system. We're just going to talk about, here's how you're going to use it in the standard use case. And then they'll learn all of the complicated stuff later. So we need to teach them how to drive, not how an engine works. All right. So one of the problems we have a lot in tech is that we have a tendency to give a set of instructions just by saying the command rather than explaining what the command is for or what it's doing without using the terminology. So the first thing you need to do in Git is make sure that you explain the words before you use them. So commit is a very strange word. It doesn't have, in Git, it doesn't have the same colloquial meaning that it has in English. So you need to make sure that you're not just throwing commands at them that have no context. They need to be able to understand instructions, not incantations that are magically going to do the right thing. So I learned Git in the worst possible way. Back in 2010, I had a sheet of paper that just said git status, git add, git commit, and then git push. So I apparently had a repo that I had set up, or someone had set up for me, and I was pushing to some repo somewhere, and I didn't know where it was, and I didn't know what git log was. And I was using that sheet of paper for about 1.5 years before I really understood how Git worked, or how to actually look up old commits. So I struggle with that a lot, and I just want to make sure that as few people as possible have to learn Git the way I did. So throughout the talk, I'm going to have examples of the incantation that we use, and then I'll have an explanation next to it, a good example of a way that you can explain it to people. I'm not going to read them as I go through, but they'll be there. Yeah, and then a lot of times when we're trying to come up with a good way to explain the instructions, we sort of get stuck on when the student doesn't understand what we're saying, we try to just say the same thing at them over and over and over again. So if they're confused by what you're saying, try using metaphors or similes. That can backfire on you if you're not very good at it. But my friend Thursday Bram wrote an article on how to use good metaphors, and she actually uses Git as an example. So that's the link to it. You should check it out. It's really good. And if you find yourself saying the same thing over and over again and they don't get it, I find it's really easy, or the easiest way to paraphrase is to try to pick a different verb, and then you will you'll usually find yourself using more colloquial verbs that they would have heard before, which can make it easier to understand the complicated stuff. All right, so we're going to start with the local workflow, getting them used to what they'll be doing on their own computer every day when using with Git. So this is the potholes part. This is the nitty-gritty stuff that they're going to get hung up on. So the first thing is Git Init. And Init is short for initialize, and I feel like we tend to skip explaining that, and it can be a pretty helpful step in understanding what's happening. And if you know for sure that your student has a pretty firm grasp of bash, I would recommend showing them what happens before and after you use Git Init by doing ls-a so that they can see that .git was put into the folder. If they don't know any bash, I would skip this step. It's just going to make them more confused. All right, so the staging area is one of the weirder concepts in Git, and this is how we usually see it taught, where it's just the steps in order on the command line. And it's important to teach this workflow, but I think there's a better way to do it by using pictures, and preferably pictures with arrows. So I tried to match the wording that we would normally see when we use git status. And you do have to teach them what working directory, staging area, and repository mean. And depending on what you know they're going to be using Git for, if you work with them, it might be a little different than if you're sending them off into the wild to use Git. So they must know what working directory is because they've apparently already been writing code in that directory. The staging area is a strange concept, and I really hate that word, but we have to use it because all of the documentation uses that word. So we need to get them used to seeing it, but try to explain it as like, this is when the files are ready to be saved. That's what the staging area is for. It's just saying this file is ready. And repository is a weird word. Good luck explaining that one. I'm still working on like a good way to explain it other than to say this is what Git is aware of and knows. This is what Git knows has changed and what has happened. But I'm still looking for a good way to explain that one. All right. So status is a command that you should get them very familiar with very early on. Like show them as many things that status can show them as possible. Show them the difference between untracked file and modified file and committed committed files. The status is wonderful. It tries to do as much to help you as possible with the coloring, and there's a lot of text there that we all know isn't useful day to day. We ignore most of that, but they're going to see that and they're going to think all of it's important. So walk them through that and show them, here's where the important bits are. These are the pieces you need to focus on. And get them very comfortable reading from status, because we don't want them to always come to us with every little problem that they have that could very easily be solved by them just looking up what status says. Almost everything is solved. Or not everything, but a lot of things are solved by just checking what status says, and we want to get them very comfortable and used to using that so that we don't have to tell them every single time. Okay, so git add. Git add is fortunately a very straightforward command, but I find that a lot of times in tutorials, if you only walk through the status add commit workflow once, they tend to think that add means start tracking the file rather than I care about the changes in this file. So make sure that they see this, you walk through this process several times and explain that add means I want these changes in the next commit, not I want Git to keep track of this file from now on automatically. And I found that on the first day of teaching Git, Git RM and Git move can be exceptionally confusing. So I would recommend using examples that don't involve those two commands. They can learn that later on. It's important eventually, but for now, let's stick to the really easy stuff like add. Okay, so like I said before, commit is a really strange concept. So before you start using the word commit, not only as a noun and a verb interchangeably, which is exceptionally confusing, start by explaining that you're creating save points. I really like the metaphor of like a video game. I don't use it much because I don't play a lot of video games. But if you do, and you know that your student does, then totally use like checkpoints and save points as a metaphor to explain, we want to be able to get back to this point. We're taking all of these changes and wrapping them up together because we need to be able to get back to this point where everything was working and everything looked exactly how we wanted it to. And also, if they're very, very new to code, a lot of people have had to write papers where they want to save, like a version and then like modify it and come back to an old version. So they've probably done that by making a bunch of different files, and you can probably reference back to them writing papers if they're more familiar with that than code. But try to use non-code examples if they are very, very new. If they're not new, then it's pretty obvious what it's for. Okay. So always, always, always for beginners, teach them to use Git Commit-m and then to put some documentation there rather than just Git Commit alone. This is a great time to sort of reinforce some good behaviors about documentation and to tell them to use meaningful notes to themselves. So if you want to see some really bad examples of commit messages, I recommend these two websites, What the Commit and Commit Logs from Last Night.
That last one is awesome.
It is. I love that one so much. It takes commits that were posted after midnight that have swear words in them and just puts a list of them. It's fantastic. So, as I was saying, always use Git Commit-m, because if they just do Git Commit, it's going to open up a window in V and ask them to write a commit. And I know how to write a commit and exit and get out of this, but for beginners, the surest way to get a random string is to just give them open Vim and have them try to figure out how to get out. You'll just get a random string of characters, and they'll be stuck and confused, and it's awful. And even if they do manage to get out, they're going to get this error message. So that's a horribly confusing process. They don't need to know how to use Vim. I use Vim a lot, and whenever I teach, I tell the students the only command you need to know in Vim is escape::q bang. That will get you out and won't save anything. It's perfect. That's all the Vim they need to know. Okay? All right, so this is a very strange confusion that I've run into several times. I'm not entirely sure what it is about the way we teach the workflow, but I've had a lot of students think that commit means push. I guess if you teach status add commit push, they might just remember push better, but assume that that's what commit was because we used it more often. Or they might just think that commit is like a step of wrapping everything up so that you can push it to a remote repository, like JSON encoding or something like that. But it's not a preparation step for something else. It's its own thing. So be wary of that. That confusion comes up a lot. And the best way I know to prevent that confusion is to teach Git commit and then Git log and save for Git push for later. So like I said earlier, I didn't know Git log existed for like over a year of using Git. And you need to teach this on day one because this is the whole point of Git. This is why we're teaching them Git, is so that they can get back to previous commits. So make sure that they get used to reading Git log. Questions at the end. Make sure they get used to reading Git log. And teach them that no matter what, they can get back to a previous commit. There's no amount of screwing stuff up that they can do. They can always get back to anything they've ever done. The history will never change, even though we all know it will. Tell them it won't. And teach them how to find the names of the commits so that they can get back to them. But don't talk about hash functions. If they already know what a hash function is, great. You can say that these are the hashes. But if they don't know what a hash function is, that's a really unnecessary sidetrack. That's actually kind of a difficult concept. So don't talk about that. Just say that it's a perfectly unique name for every single commit. And this is where they can look it up at the end. Okay. So another tool for looking for answers is Git Diff. A lot of the problems they run into, they will be able to solve if they can just see what they changed rather than trying to guess from what they saw in Git status. So teach Git Diff right away. And teach what it does when they have made a bunch of changes but haven't committed, and show what it does if they do Git Diff on a specific hash. This will help a lot later on when they have really straightforward questions but didn't know how to look for it. So always teach them to use Git status, Git Diff, and Git log to go find answers on their own. And then to come to you after that didn't give them the answer. Okay, so that's the basic workflow. Now we're on to branching. You can teach branching and remote repositories in either order depending on what your beginners need to know. There's benefits to teaching one before the other or vice versa, but really it's fine either way. Okay, so early on when you're teaching branching, just set the computer aside, get a whiteboard or some paper out, and start drawing some trees. Start showing them like what the structure will look like as they get into more complicated projects. And like teach them the workflow that you want them to be using by drawing the tree of what it should look like. They don't need to understand the graph theory of it. We can probably like try as hard as you can not to use graph theory terms like vertices and edges. That's another sidetrack that's not going to help them understand what's going on. Try to focus on getting them used to seeing the history and so that they know what they're working towards, or showing them the tree structure so that they know what they're working towards. Okay. So the branching metaphor helps a lot in teaching. It's going to do a lot of the work for you, but I would like to point out that early on, try to use as few of the flags as possible. They're not going to need to know some of the difficult stuff like git branch -d. Like if they have extra branches lying around, it's not the end of the world. But for now, teach them the really basic stuff so that they don't start to see these as incantations. The branching structure is very straightforward. And I wouldn't recommend creating a branch and navigating to it in the same step. Breaking these up into smaller pieces will help them understand exactly what the commands do rather than combining them together. And I used goat in the previous slide to set up for this dumb joke. Anyway, that's the goat branch, and now we're going to try to merge it. So another term that we think means something but doesn't if you're a beginner is master branch. We're so used to hearing it that it feels like those words have meaning, but they don't. So just explain that master branch is just generally what people use to mean the good version of our code, and that there's nothing special about the master branch. It's exactly like all the other ones, except for that it's what Git will default to using. A lot of times they'll think that there's something special or different about the master branch that they need to like be extra careful about, but they don't. They should try to keep it clean, but not be scared to use it. All right. So git merge. Once you start teaching branching, you need to start teaching merging, because otherwise, why are they using the branches? And when you teach merges, you need to teach them merge conflicts, because no matter what, in every project they run into, they're going to have merge conflicts, no matter what. And if they were to come across this on their own, they're just going to see conflict in big capital letters, which is really scary when you're a beginner. And it seems like a really terrifying error, but it's not. It's a really straightforward, easy-to-fix problem. It's just the computer saying, I don't know what to do, and I need a human to help me. Because computers are dumb sometimes. They're actually dumb most of the time. So there's a lot that they're bad at. So pick something that will when you walk your beginner through this process, pick something that'll definitely error or give them a merge conflict. I usually just do imports and put them in a different order. It's very easy to see in this example that a merge conflict doesn't mean that there's something horribly wrong in your code. It just means that like something's in a weird order and the computer didn't know what to do. So I like this example. And you can show them they just need to find the angle brackets, the equal sign, and the other angle brackets. And then just tell them that they need to delete those lines. Like there's usually probably something weird in there in between, but they can keep any part of that. They can delete all of it, keep some of it from above, some of it from below, or they can keep all of it. The only important thing, the only thing Git cares about is deleting those 3 lines. So that should make them a little bit more comfortable with the structure once you explain that it's always going to look exactly the same and that Git only cares about those characters. And then once you close that up and commit it, show them git log again. Show them what Git did with that information so that they know how to read git log and look and see what a merge looks like in the history. And then I don't like teaching head on the first day. It's a weird concept that they can usually get by for a little while without knowing, and it's easier for them. It's easier to understand it once they've gotten familiar going through this process for a while. If I had to explain it on the first day, I'd probably just say it's like a "you are here" sign, but ideally don't mention it. Okay, so moving on to remote repositories. Again, you can teach remote repositories in branching in either order. It really doesn't matter. So these are the worst commands in Git that they are definitely going to need to use. I hate them so much because they've seen a couple of those words before, But they don't mean the same thing, and these are like the longest commands they're going to see, and that -u is short for set upstream, which is probably a word they haven't heard before. So there's a lot of information crammed into 2 commands that look really scary. So have fun teaching those ones. I have sort of waffled, or I've struggled to decide if I want to break those up into, or break up git push -u origin, or -u origin master into 2 commands where we set upstream separately from pushing, because when a command has 2 outcomes or 2 side effects, that's really difficult to remember like what part of the command was important and which one they're going to have to use later on. And it would be really weird to set upstream every single time you pushed, but sometimes they'll just get used to seeing that command. So I wish I could break them up, but every other tutorial that they're going to look for and like all other documentation is going to recommend that they do this when they see it the first time. So I tend to use these commands even though I don't like them because I want them to see them in the documentation and recognize them and be comfortable and like know what they do. So yeah. But try to explain the meaning of origin and upstream before you do those commands. Origin, exactly like master, is just a word that we always use. It's not special in any way. It's just the convention. And upstream is another one that I really struggle with explaining if they don't have any experience writing code before. If they've gotten used to like taking other people's code and like trying to keep up with like the latest version of something, they probably already can kind of have the concept of upstream. But if they're brand new to programming, then that's a really difficult concept, and I'm not really sure how to teach that without some programming experience. Okay. All right. So the most important thing about git clone is that when you're first teaching them this, don't use SSH. Use HTTPS, because walking through the process of SSH keygen is an unnecessary tangent that's really confusing, and you're going to be going and looking at files that aren't in the working directory. And if they're very new to Bash, they might not know what invisible files are. So that's a very unnecessarily confusing process. And if you're going to use SSH keygen and give them a public and private key, you need to be able to take the time to say, never post your private key anywhere. If you're not going to teach them the safety, do not give them SSH keys. And as a beginner, they don't really need SSH. It makes things go a little faster, but they don't need to go faster right now. Right now, they need to know what their username is, what their password is, and to make sure that they're pushing to the right place. So HTTPS is the easiest way to go so that you don't have to go on this unnecessary sidetrack that's just going to take up time, and they're going to feel like it's really important. If you've taught it correctly, they'll feel like it's really important, but not super important to Git. All right. So git pull and git fetch, kind of, at the very beginner level, they kind of do the same thing. They're just a way of going and getting code from somewhere else. And I don't think you should teach both of them on the first day, because they're going to spend a lot of time worrying about which one they need to use in specific situations when it probably doesn't matter. They're not going to have weird-looking repos at the beginning, so it doesn't super matter. So just pick whichever one you like better and teach them that one and teach the other one later. And then pull request is a weird one because they're not pulling anything like they do with git pull. They're asking someone else to pull. So when you get them used to working with others, explain pull requests and don't assume that they'll just know what it means. It seems obvious to us, but it's not obvious when you're a beginner. And if you have a more technically advanced audience, you can teach them that git pull is just git fetch plus merge. They probably will be pretty, they'll probably not have too much trouble understanding that concept. But at the beginner level, don't make it any harder than you have to. Okay. And when you're teaching the repositories, I've found that GitHub is probably your best option because it's free and there's just so much documentation. So when they have to go back and do this on their own, they don't have to come to you to ask for help because they can Google any question related to GitHub, and they're going to get some really well-written documentation. And the UI is really straightforward and useful. So I really like GitHub. But it does have the problem that all of the documentation is very GitHub-centric. So GitHub is going to assume that anytime you're using Git, you're using GitHub. which your student doesn't necessarily need to do. And I've had a lot of students that will tell me that they've learned GitHub, and I'll clarify, and they actually mean Git. So just be careful when you're teaching GitHub that they understand the difference between which commands are from Git and which ones are from GitHub, because trying to find the man page for fork can be really frustrating. Okay, and so this is all the stuff you should not teach on the first day. And I'm so serious about Rebase. I love Rebase. I use it all the time. I'm, if anything, using it more often than I should. It's super handy, but don't teach it to them, because we're going to try to teach them that the history is immutable, that it's always there and it can't be changed. And they're not going to believe you if on the first day you're like, but I know a really cool way where you can rewrite history and you can accidentally delete things and make them go away forever. But don't worry about that. There's a safety net after that. You still have reflog. And I don't want to teach someone to read reflog on the first day. So do not teach Rebase, or amend for that matter, because it's the same problem. Just let them trust in the fact that the history is always there, it can't be changed, and it's always there to protect them. So I think this is all like learning physics. Did any of you take like low-level physics and then take it again at a higher level? Okay, so if you take physics at a very low level, they'll be like, this is Newtonian physics, and it's this perfect, beautiful, concise thing, and this is how gravity works, and we know it works this way. We know exactly how it works. And then as soon as you get into higher level physics, like theoretical physics, they just say, we have no idea how gravity works. It's a complete mystery. So it's the same thing with the history in Git. At the very low level, they just need to trust that it's there to protect them, and it will always protect them, and there's no way they can delete stuff. It's there forever to save them. Don't teach them Rebase. They can learn about theoretical physics later. Okay. All right. So as I was saying, we just want to make sure when we're going through all of this, to avoid using the incantations that just magically do the right thing, hopefully. We want to try to explain our terminology and give them a context around what we're teaching, and try to paraphrase it as many ways as possible and use language that they would have already heard before. Don't just say the commands in order. That's extremely confusing. And teach them to get information from their computer, because I don't want to answer the same question every single time when it's always the same problem. Status, diff, and log will help them get most of the answers that they want to know. And then don't give them any information they don't need right away. Like, they can learn all the rest later. On the first day of Git, we just need to get them like comfortable seeing the commands. They don't need to know what hash functions are. They don't need to know weird commands that you didn't use for like the first several years. We can get away with not teaching everything Git can do. And then draw pictures, because Git is conveniently very easy to draw, but it's very conceptually difficult if you can't see what it looks like. All right. Yay, we have enough time for questions. Okay, any questions? Yes.
Well, okay, basically, my question is not a bit related to this, but it's teaching the same Git. But how can I tell them how important it is to learn Git, but not because everyone is using it. I want to how can I explain to them that the real benefits of using Git in their code, because it's more like, oh, every software developer is using Git, you should know Git.
Yeah, I would say just ask them if they've ever been working on a project and they got something to work and then they broke it and they didn't know what it was like when it worked. The video game metaphor also helps here. Like, whenever you get to a point where you have something that's like, okay, this is what I want. Like, this part, I got it right, and I just need to make sure I don't screw that up while I go work on this other piece. I think that's what they need to hear, is that Git is there to protect themselves from destroying everything they've made. It protects yourself and others from yourself and others, because no matter who screws up, everybody can safely get back to a version of the code that worked. Yeah. And also backups. Git's really helpful for backups. That might be a more straightforward way if you don't want to get into all the complexity of version control. Yeah.
Yeah. When you were mentioning that, like people confuse the terms commit and push.
Mm-hmm.
I'm thinking that maybe the confusion stems from the fact that people don't wrap their head around the fact that your repository is initially local. It's fully local. So like you don't have anywhere to push. But I've seen this happen with people that have used other software version tools.
Yeah.
Say SVN and stuff. That people don't wrap their heads around the fact that you have a local copy of the entire repository. It's not.
Yeah, and I will say that if your person is new to Git, has a background of Subversion, it's a very different. The confusions are very different. If they're brand new to version control, this is why I think you should walk through the status add commit process locally several times so that they can see how to get back to stuff that they've done locally and get used to the idea that Git works on your computer, and then separate push out into like a separate process. Like make sure you're establishing that that's not necessarily a part of the Git workflow. It is only for when they have a copy that they want other people to use, or they want to make sure that they have a backup somewhere other than on their computer. Yeah.
I tried to teach some friends that were technicians to use Git. They're not programmers.
Mm-hmm.
And they asked, the first thing they asked me was, what about the graphical interface?
Oh, yeah, okay, so I don't know how technical they are. If you have to use a graphical interface, my favorite one is Gitbox. I think the way it visualizes things is conceptually very true to how you're supposed to use Git. I'm not a huge fan of the GitHub application. The person I know who liked it the most explained it as it would take the commands, and instead of making you do every little atom, every tiny little piece, it would just wrap them all up and do it for you in one command, which to me sounds like a bad idea. They should probably know what the individual pieces do. And also, if they're very beginner, you can just have them make changes on GitHub. Like if they're never going to use the command line ever, you might be better off just using the GitHub UI. But Gitbox is my favorite if you have to use a graphical user interface. Yeah.
Yeah. The question is, have you ever talked to people that is not developer and, for example, I don't know, civil engineer or architect or something like that, or journalism, or
That has used Git?
yeah, for example, because
Yeah.
what I see too much is, for example, my project.final.1, my project.final.2, and
Yeah.
it's difficult for me to convince them that, for example, Git or a similar tool will be a benefit for them.
I mean, if they're not a developer, they might not. But if you really want to teach it to them, I would recommend saying that it will save space and that they can't accidentally delete it. That Git will keep a record of like all previous versions and they won't be able to accidentally delete it, and that there's already a system built into Git to make it easy to back it up somewhere else. Yeah. And also, if they're a writer, bgit is a blogging platform that's built on top of Git, so it will teach them. I mean, it hides a lot of the pieces from them, but it does use Git to keep track of versions for them.
Which one, sorry?
bgit, like the animal, B-E-E-G-I-T, bgit. Yeah.
So, thank you, Git's really helpful. I have some friends who are trying to use Git. One of them wants to use it for, as an example, a video editor. He wants to upload video files.
Okay, so Git is not a tool to, sorry, finish.
I don't know how to, other than like the file limit size, I don't know how else to explain to them. This is not.
You might have to let them fail. he'll probably see how poorly that goes pretty quickly. But also, Git is not a tool to manage, to keep track of different versions of computer-generated anything. Yeah, or even code generated by computers, because they're not very good at making it consistent either. Git is a tool for managing files that were edited by humans. Like, it can keep track of changes that humans make, but it's not good at changes that computers make.
Yeah, that's why we have ignore file.
Yeah, oh, that's another thing. If you can avoid it, don't teach git ignore on the first day. It's, like, just have them leave the .pyc files as untracked. And then once they get really annoyed with that, after a couple weeks, then teach them .git ignore. They'll appreciate it more, and they won't accidentally ignore something important. Yeah.
There are like the nice, like you can get, if you're doing a Python project, just like throw the like pre-made Python .git ignore in there,
Yeah, I mean, there's lots of projects where they have like all the settings for the virtual env ahead of time, and they like have all the settings for Git ahead of time. If they're working on one of those tutorials, then like, yeah, they should definitely follow the tutorial. I find it's just a concept that they don't need to know right away. But if you have plenty of time, and if it's someone that you're going to be working with regularly, so you know you can clarify everything as they go, then yeah, go for it. Any other questions? Oh, okay. So this is over. I'll be in the hall. You can ask me questions. There's my Twitter handle. I'll be posting the slides at that location sometime in the next day or two. And then there's a written version of this talk in the Recompiler magazine at that link.